All right, we're broadcasting. So while let me put my face on here for a minute. Hey, so just in case you're working on your review for tomorrow's test and wanted some extra help or to see the answers, I'm going to do that in a few minutes. I just sent the link out, so I'm going to look here and watch to see if any viewers show up. And truthfully, I'm going to be watching the hockey game while I'm waiting. Hey, there's one viewer right there. Look at that. Alright, let me look. Viewer, see who it is. If you don't have the, wherever you are, I'll try to see in a second. If you don't have the PDF or your own sheet of the review questions up, that might be good too. But it's going to be right here, those. Didn't mean to do that. Alright, let me look for a second. I just realized I need to turn down the hockey game. Alright. Iron this out. Put that back on there. Hey, we got another viewer. Alright, so let's just start here. Well, before we do this, remember that there's three main ways that we can solve systems. Well, before we do this, remember that solving systems methods. Main way to solve systems. Hang on, I need to get myself out of here. I had a feedback loop. Okay. I will not hear myself any longer. Okay. Solving systems methods. It's getting up there. You know, we can graph them. We're looking for where they intersect if we were to graph them. Let's say that was a line and that was our other line. Remember, our intersection would be right there, whatever that point would be. We can, wrong pen. We can solve by substitution, where we solve one for the x or y variable and then plug the other one in. And we could solve by elimination. It's going to be up to you to determine tomorrow which method you use. But know that I'm going to expect that you'll be able to use any one that you want in theory on this. I'm not going to have any questions where I say that you must use graphing or must use substitution or must use elimination, but I'm going to choose ones that will be better for others. Alright, so leave that up there for a minute. So I'm just going to go through a few of the questions now. You see these two from that sheet. I'm also just going to do the ones that have equations already. I'm not going to do any of the word problems for tonight. You'll see these two equations. Neither of them are in slope-intercept form right now, so that's not going to be easy to graph. So the first thing I need to do is put it in slope-intercept, that mx plus b form. I'm going to ignore these for now, so I can focus on that. Alright, so x plus y equals 4. I'm going to put this in slope-intercept form by moving the x over. Notice I got to get the x and the b together. So then this top equation we can rewrite as negative x plus 4. And this one here, we'll call it the blue one. X minus 4 equals y over 2. To put in slope-intercept form, I want it to be set equal to y, which means anything that is being operated against y, I need to undo. So right now this is y divided by 2. If I multiply everything by 2, then I can undo that. So over here it's just going to cancel, and I'll have y. On the left side I need to distribute. 2 times x, 2 times negative 4, give me 2x minus 8. And now I'm ready to graph. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Any graphs you need tomorrow will be on the paper already. I'll have graph paper for you. Alright, red one. The y-intercept is 4. The slope is negative 1 over 1. So we'll go down 1, right 1, down 1, another, and go up and left, and draw the line. The green one I have there, the y-intercept is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. That slope is 2 over 1. 2, right 1. 2, right 1. 2, right 1. 2, right 1. I'm wondering if I should have intersected right there, so I'm going to be a little more precise about this one. Down, over, down, over, down, over, down, over. Okay, so that line should have been going through right there. The red one. Draw your line. Where's that point of intersection? It's right there. So the solution to number 3 on this page is the xy point that's right there. 1, 2, 3, 4x, and 0y because it's on the y-axis. I'm gonna open the chat real quick. No one's chatting. Let's check the YouTube real quick. No comments there? Okay. She could email me maybe too if you happen to get a question. No emails. Alright. Let's go ahead and take a snapshot of that just in case, and we'll do the second one. Ignoring that one. Neither of these are in slope-intercept either, but getting them there will be very similar. 6x plus y equals 6. I want to move the x over, so I'm going to subtract 6x. with a 0 there, and I've got y equals negative 6x plus 6. I can't add those together because they're not like terms. And the second one, 4x minus 4 equals y divided by 4. Just like on that one we just did, there is a 4 dividing on the y. I need to undo that division so I can multiply everything by 4. Over here it's going to cancel, and on the left side we'll distribute. 4 times 4 is 16. Ooh, this is gonna not be fun to graph. 16x minus 16 equals y. Okay, let's graph this. Lots of lines. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm hoping they're going to intersect just here on the x-axis because of what the slopes are and what the y-intercepts are. Let me check my multiplying real quick. Okay. I drew my lines the wrong way anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to have to assume. Alright, let's do the red one. 1, 2, 3, 4, 5, 6. For the y-intercept, the slope is negative 6 over 1. Down 6. 1, 2, 3, 4, 5, 6. And right 1. Down 6. 3, 4, 5, 6. Right 1. Let's draw our line. Let's do the blue one. The y-intercept is negative 16, so that point is somewhere down there. But once we put that point on the graph, then it would be coming up 16, right 1. So it's actually going to put us right back there. And then I'll go ahead and count up my 16 over 1 more time, just so I can draw my line. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 over 1. Alright. This line is snaking through there. Alright, where do they intersect? You see they intersect right there. The solution that we found graphically is x of 1, a y of 0. Alright, so there's two graphing ones. Just in the interest of time, I'm probably only just going to do those two graphing ones. If you want to go back and watch this, the good thing about Hangout on Air is that it stays on that YouTube channel, and you will always have that link. Alright, so again, graphing might not be the best method because, as you can see there, I had to do a lot of point counting, and I had to do some algebra to get these to be ready to graph anyway. I had to solve them for y and put them in slope-intercept form. So if they are maybe in standard form like those two, or well, these were also, maybe you might want to use elimination instead. So again, graphing, if you're good at graphing, is a great idea to do that. I'm going to let you graph like crazy tomorrow, but it's not always the most efficient method. Sometimes if you have a lot of calculations or a lot of steps to do, then you're going to want to use the most efficient tool for what you're trying to do. Let's take a shot of that. And I'm going to go to another problem. I've taken a screenshot of the PDF on my iPad here. We'll just go to 5. 5 says to do elimination. Okay, there's 5. Alright, remember to do elimination we need the variables lined up. Stacked so that when we add down things will eliminate. Variables lined up. And so that things will cancel we need opposite signs on one of the variables with the same coefficient. Coefficient, remember, being that number in front of the variable. Variables lined up, opposite sign, same coefficient. I don't have that with this right now. So looking at my x's, if I multiply -3 by 2, I can make that 6. So that's an option. If I wanted to eliminate the x's, I could multiply this whole bottom equation by 2, and then I could get the x's to both be a 6 and to have opposite signs. So that's an option. If I wanted to eliminate the y's, see, those are opposite signs already, but 8 is not a multiple of 12, so if I wanted to do the y's, I would have to multiply both of the equations. I'm going to model both of those scenarios real quick. Let's say I wanted to eliminate the x. If I multiply this whole thing by 2, that top one we're going to keep the same. 6x minus 8y equals -54. And then on the bottom, multiplying everything, I'd have -6x plus 24y equals 198. That's 99 times 2. And then when I add it down, 6 and -6 would cancel. I'd have a 16y here and a 144 right there, I think. Check my math if you're watching there. Alright, so I could eliminate the x. In this alternate reality, where maybe I wanted to do the y's, I got to think about the least common multiple of 8 and 12. If I'm thinking about my multiples of 8, I've got 8, 16, 24, 32, 40. I'm thinking about my multiples of 12. I know there's 12, 24. I'm going to stop right there because I found the least common multiple of 8 and 12 is 24. So I can get 24 as my y's, and I'll be able to eliminate the y's. That would require multiplying the top equation by 3 to get those to 24. And the bottom equation by 2, just like we did on the last one actually, so that I can get the x's to be the same. Alright, so if I were to be trying to cancel the y's, 6 times 3 is 18x. 8 times 3 is -24. That -8, I mean. And 54 times 3. Let me calculate here. -54 times 3 is going to be -162. And then doing everything on the bottom by 2. -6x plus 24y equals 198 again. Okay, and you'll see this time, if I had done that, when I add down, 18 and negative 6 is 12x. Negative 24 and 24, that's a 0, so those eliminate, which was our whole goal. And negative 1, 62, and 98 is 36. So in this case, I'm solving for y if I had eliminated the x's. In this case, I'm solving for x right now if I had eliminated the y's instead. Whichever one you do first, that's a choice up to you. Whichever you're most comfortable. On this one in particular, I would have eliminated the x because then I would have only had to multiply that second equation. So I'm going to erase this. It's not quite the preferred method on this one. So again, I did this whole equation by 2 so I can get those x's coefficients to both be 6. I added down right here, the x's canceled out, and I've got 16y equals 144. I'm going to divide by 16 to solve for y. And that gives me y equals 9. Once I get a y in my solution, I always need an x and a y, remember? So let's go ahead and plug our y in there. But I need an x. I'm going to take that y and put it into either one of the equations. I'm going to choose that second one just because I'm going to choose that top one because I don't know, it's just I and me. Sometimes if the coefficients were smaller, you might want to choose one or the other, but these are both, there's some larger numbers and some smaller numbers. So plugging in the y, 6x minus 8 times 9 equals negative 54. Now we're solving for x. 6x minus 72 equals negative 54. Add 72 to both sides. 6x equals 18. Divide by 6. And your x would be 3. The solution is the point 3, 9. For number 5 there. Let me check the YouTube, see if there's a question real quick. Nothing there. Check the email. Nope. Let's do one more, and then I'll kind of do a wrap-up chart. Take a picture of that. Let's find a different one to do, preferably with substitution. Oh, okay, I lied. I'm going to do this elimination question real quick, just because it'll be quicker. Alright, this one here actually said choose the best method, but I'm telling you this is set up primarily to be an elimination question because of the coefficients they have on the y's there. I could go through all the trouble of trying to graph these or do substitution with those, but the writer of this question that I used set up that was to be -2 and +2, so that you would say, hey, this is a great opportunity for me to add down and cancel out those y's. So let's do that. Again, I can do that because the coefficients are both 2 and the signs are different, so they're going to cancel out when I add down. 7x and 5x is going to be 12x. 8 plus 4 is going to be 12. Let's solve for x by dividing by 12 now. X equals 1. Let's come down here to my solution. X is 1. Let's see what the y is going to be. Plug it in. I'm going to choose that bottom one just because 5 times 1 plus 2y equals 4. Five plus 2y equals 4. Subtract 5. Make sure I'm doing this right. Put my x right there. X was 1. 5 times 1 plus 2y equals 4. Okay. I didn't remember seeing on the key that any of these were going to be fractions, but that's okay. If you show up tomorrow with this is an answer, then I'm going to applaud you for getting it off of here, if it happens to be wrong. Alright, so I'm solving for y here. Let's just keep that a fraction. Negative 1/2. There's my solution. 1 comma negative 1/2. Okay, now let's get a substitution. Then we'll wrap up with one more little chart. I can't seem to find one. That one will work. This is number 8. Number 8 actually says use elimination, but I'm going to use it as an example of how you could do substitution anyway. If you bring that in and solve this way, because that's the way I did it, then that's fine. Alright, remember, for substitution, we need one of these equations solved for the variable. I noticed as I was looking at these questions that those are 6's all right there, so this is going to be pretty simple to solve for the variable actually. So let me solve this for y. 6x minus 6y equals negative 6. I'm going to get y by itself here. I'll subtract 6x. That's a 0 right there. Negative 6y equals negative 6x minus 6. Let's divide by negative 6 to undo that multiplying. Divide negative 6 over here on everything. Y equals negative 6 divided by negative 6 is just 1. And negative 6 divided by negative 6 here is positive 1. So now instead of that standard form equation, 6x minus 6y equals negative 6, I've got a slope-intercept equation that I can plug in for the y into the other equation. This is the substituting part. I'm going to take that y chunk and put it right there next to the 18. Negative 4x plus 18 times, here we go, x plus 1 equals 116. Keep the negative 4x, distribute, keep that in red, 18x plus 18 equals 116. Let's combine like terms. Negative 4x and 18x is 14x plus 18 equals 116. We're solving for x. Let's subtract 18. Calculate. Yeah, I noticed I just got a new viewer there. When this is over, this is the last example we're going to do. You can go back to the YouTube link and view all of this again. Feel free to ask a question in the chat if you're on Google Plus, or go ahead and email me at ccbaker@fergflow.org if you have a question off of anything on here. Right now I'm doing, this was a number 8 from the review, and we're doing it with substitution, remember, even though the directions on that one said to do elimination. Alright, calculating, that's what I picked this up for. 116 minus 18. Why am I doing that? I can do that in my head. 14x. That was good I looked up though, because I saw somebody else got down. 14x equals 98. We'll divide by 14. That's a 1 there. X is 7. Let's plug that into our solution. And we need a y. I'm going to take my x and put it right here, because this equation is already solved for y, so that will save me any algebra. Y equals 7 plus 1. I plug my x in right there. Y equals 8. And you're solved. So let's wrap up just with a little chart kind of reminding you of what's already in your systems booklet that we made in class, of just which methods to use at which times. Graphing is probably going to be best if they are already in slope-intercept form, both of them. And if the solution comes out as an integer. Meaning not a fraction. If you were to graph the two equations in a system and they came out to be something in between two integers, any kind of decimal or fraction that you would have to be estimating, then to get a more exact solution, then you need to go and do substitution or elimination from there, so that you're not estimating in this scenario. Like I said, the very first day that we started to do systems, sometimes when I've used systems for myself and looking at when I was going to start saving money on our new cell phone plan, when I was let my wife know what I was going to do over the summer, or when we were seeing when our new blender that we had to buy to make some food for my son with allergies, those didn't need exact solutions, so graphing was fine there. But especially on a test like this, you're going to need an exact solution. So if that were to happen tomorrow and you graph it and you got not an exact solution, then you would want to still do another method. If we wanted to do substitution, anything that's set up actually to graph, if they were both in that y equals mx plus b form, would be good for substitution too, like we saw on the do now today in class actually. So actually you can do that if that's in slope-intercept form also. Because what you really need is just one or both equations set equal to the variable. to x or to y. So as an example, if I gave you a system like that, that would be easy to graph because it's in slope-intercept form, but it would also be pretty easy to use substitution because they're both set equal to y, so your next step would be to set them equal to each other and then solve for x. Or you might have a case where one of them is in standard form maybe. And then the other is set equal to the variable already. In this case, I'd take that chunk set equal to y and substitute it in right there. Or I might be really easy on you and even just say x equals 2, and then you would take that x and dump it right there so you could get a y. And our third method was elimination. I told you in your notes the first time that you would want to be in standard form. And then we matured our understanding a little bit just to know that we need the variables stacked up on top of each other so that when we add down, that I'm adding y's to y's and x's to x's and numbers to numbers. So I'll write variables stacked. And remember that you need the same coefficient before that will work with opposite signs. Sometimes you might have to multiply one or both of those equations to make that happen. I'll do one more tiny example there of that using these numbers I just used for the other one. Alright, so let's say I had 2x minus 5y equals 4 here. I couldn't multiply the x's to get one or the other as a multiple, and 2 and 5 are multiples of each other, so whether I chose to eliminate x or chose to eliminate y first, I would have to be multiplying both equations. In this case, the y's would actually be a little better to eliminate because you see the signs are already opposite. So the least common multiple of 2 and 5, let's see, 2, 4, 6, 8, 10, 5, 10. So I'm going to multiply these. I would multiply these to get them both to be having a coefficient of 10 on the y. So I multiply that top one by 5 and the bottom one by 2. Give me 15x plus 10y equals 15, and 4x minus 10y equals 8. So now you'll see that set up, if I were to add down, that those would cancel, and I'd be able to solve for x. Alright, so if you watch to the end, here's where you get the super secret bonus. Let me save this. Tomorrow's test will be matching. What I mean there is I'm going to have, I think, about 10 questions, and a lot more answers. That all the answers will be on the test, but there will be a lot of extra ones also. So it'll be a little bit like multiple choice, but a little different in the sense that if you accidentally match the wrong one on your guessing, then you automatically get another one wrong. So there's the tip for you. If you stuck around to the end, let me unshare my screen so I can show you my face again. Thanks for viewing. I hope this was helpful. Tomorrow, again, you can use your notes booklet, the blue one we made in class, on your test, so you can have those examples. I'll be looking that you have the review study guide done, a lot of work, and as soon as your test is done tomorrow, then we'll get started back on that little card sorting activity that we were doing. Alright guys, good night, good luck.